Concentric muscle contraction. The sarcoplasmic reticulum releases calcium into T tubules. Calcium binds to troponin and initiates contraction. It moves the tropomyosin to expose actin binding sites, which initiates the cross-bridge cycle. ATP hydrolyzes and causes the transition from the 45 to 90 degree conformation of the myosin head. Release of inorganic phosphate causes strong binding between myosin head and actin binding site. This initiates the transition from the 90 to 45 degree conformation. Release of ADP from myosin head completes the transition from the 90 to 45 degree conformation. This moves actin filaments more towards the center of the sarcomere, or M-line. Binding of ATP causes formation of a weak binding state between myosin head and actin binding site. The sarcoplasmic reticulum sucks the calcium to allow another cycle to begin. Eccentric muscle contraction. During eccentric lengthening of the muscle, myosin heads are ripped off and reattached without the use of ATP. As you can see, the Z line is no longer visible because it stretches as the muscle lengthens. If the muscle begins its contraction at a very short length, actin and myosin have a lot of overlap. The sarcomere cannot shorten very much before the myosin filaments run into the Z disc at each end. There's also another theory of describing too much overlap. Shortening muscle fiber increases the actin-myosin distance so they are unable to bind. Length-tension relationships. Sarcomere length affects actin-myosin distance. If the resting muscle is stretched, filaments in the sarcomere barely overlap and cannot form as many cross-bridge links. Stretching a muscle fiber reduces the actin-myosin distance.